Okay, for this problem, we're asked for the leading coefficient. Well, the first thing we want to do is put it in standard form or descending order. Notice that x to the 5th power is not in front. It needs to be in front. The biggest exponent always goes in front. It's the order of the problem. It's what kind of rules over time. So I'm going to go ahead and reorder it. So just be careful about the signs and make sure it's in descending order here. So this is going to be equal to our f of x is equal to the negative x to the 5th minus x cubed minus 3x. Notice the biggest exponent is first, then the next biggest exponent, and then that's an exponent of 1. All right, so then it wants the leading coefficient. So this is the leading term right here. It's the biggest exponent. This is called order 5 because the biggest exponent is 5. If you had different letters here, and sometimes you do, you would want to add all the exponents of the letters as long as they're not constants. Sometimes the letters, they try to trick you and make them constants. But if they're our normal variable letters, then we add all the exponents. That's the order. We only have one letter here, so we just look straight at it. So our leading coefficient is the number in front of this. So the number in front of x to the 5 is a -1, even though we don't see it. This is also a -1 for that coefficient and a -3 for that coefficient. But our answer here for the leading coefficient is -1. Next one. This one asks for the real solutions of this problem. It says real so that we don't have to worry about the complex solutions. So we're just focused on what do we see here. Well, let's use some different words for real solution. Another word is root. What are the roots? Or x-intercepts. Well, that makes it a lot easier. If we remember that real solutions are the x-intercepts or the roots are the x-intercepts, then we can just look at the graph here. So x-intercept is the easiest because we're dealing with a graphical situation. If we were dealing with the equation, the root word would probably come out more because we're finding them usually as roots. So let's go ahead and look at where they're at. The real solutions, I'll just go in order here. It's always good to go left to right. So usually we have a set notation for something like this. I like to tell my students always write it as a point. So I'm just going to go ahead and write it in set notation and then write it as a point. So this is x equals. These are the real solutions. So it's just good to know that y is equal to 0 for these. That's what it means to be a root or an x-intercept. And our first one is 1, 2, 3, 4, -5. The next one is 1, 2, -3. The next one is 1, 2, 3, 4. And the last one is 1, 2, 3, 4, 5, 6, 7, 8. And it's a brace, not a parenthesis. There's my brace. So what the real answer to me would be -5, 0, -3, 0, 4, 0, and 8, 0. Just as a note, in the program that we're using to do this, you have to type the parenthesis in, you have to type the comma in to open up the next cell to write your answer. Got that one. All right, the last one here, write a possible equation for something like this. Well, we just studied our parent functions. Does this remind you of anything? Well, it has 2 bumps. So anything that has 2 bumps usually has 1 more than that as the exponent. So 1 more than 2 is x cubed. So this is like x cubed, y equals. Okay, but we actually have some solutions here, some roots that they've given us. So we want to use that to build kind of binomials to help us out with building this structure. So the first one here, we have a root at -4. So we write it as a binomial, x minus 4. We can kind of think about this. This is where y is equal to 0. So it's not minus 4, it's plus 4. And it's kind of good I brought it up too, because this is like y equals 0. If I set this equal to 0 and I solve for x, I would subtract 4 from both sides, and that's where it crosses at -4. So if I plug -4 in for x, I get a 0 for y. That's the other way of thinking about it. The next one, so it touches at 1. Notice it bounces at 1. What would I write here, do you know, for that binomial? Well, it's like if I plug 1 in, it would 0 out. If I plug 1 in for x, if I plugged 1 in for x, it would 0 out. So what plus 1 makes 0? -1. -1 on that one. And whenever you have a bounce, it's kind of a trick. It means it gets doubled up. So this one is kind of like a double root, usually in those cases. And we got an x minus 1 again, because it's bouncing at 1. So we can just kind of confirm, if I plug 1 into here, I get 1 minus 1. That makes 0. It zeroes everything out. That's 0 for y. Same thing for here, exact same rationale. And then the last one, if I plug -4 in for here, that's -4 plus 4, that turns to 0. 0 times anything zeroes it out, and y is equal to 0 on there. So, and notice that this is x times x times x, essentially. So it is like an x cubed equation. The order here would be 3. It's like a cubed equation.